Hello, my name is John Dowling and I'm going to take you through the presentation on legislation and trends in structural fire protection. This is the shortest of today's talks. That is a picture of the aftermath of a fire in a very large building. These fires are mercifully very rare. To give you an idea of how rare these fires are, this particular fire happened about 20 years ago. And I still use it because I've never come across a better one. The fire started on the 8th floor, completely gutted the 8th floor, completely gutted the 9th floor, very badly damaged the 10th floor before it was eventually brought under control. And in terms of direct damage, that thing cost about 19 million pounds in early 1990 prices, probably around the equivalent of maybe 40 million now. And that was the bad news. The good news was that the building was owned by an insurance company. So But the building, a big, huge, severe fire, and the building's still there. There was actually no structural damage. If you'd gone into the building afterwards, this is what you would have seen here. And that building was fire protected by a very common combination of fire protection materials at that time. A spray protection system on the beams, which we'll see more of later, and a board protection system on the columns. That building had 90 minutes fire resistance. It was fire protected to resist a fire for 90 minutes. It survived a 4-hour burnout. It survived with no structural damage, and in fact that building was fully reinstated. That shows two things. First of all, it shows one thing in particular, that is that if we get our fire precautions right, if we get the fire protection in there right, we get our precautions in there right, the buildings are safe, our rules are good. That particular building had 90 minutes fire resistance. About a couple of years later they changed the rules, and a building like that would have had 120 minutes plus a sprinkler system, which tends to show that perhaps sometimes our modern rules are too conservative. And again, that's a theme which we'll build on through the day as well. But if you get it right, the buildings will be safe. We live in a society where our building regulations are couched in functional terms. Our building regulations set out what the legal requirements are for us as engineers, for people who are responsible for making sure that buildings are safe. They're couched in functional terms. In other words, our building regulations will tell us what to do, but not how to do it. And what I've done there is just I've taken two elements, two small excerpts from the building regulations. One of them covering stability and one of them covering spread of flames. But that tends to be the way in which they're couched. They're very simple, they're very, very straightforward. But the building regulations don't tell you how to achieve that. But fortunately, what the government does is the government produces approved documents. You'll all have seen approved documents, and that's what approved documents are. They are ways of interpreting the building regulations. They're not the regulations themselves. The approved document B covers fire, and its status is that if a contravention is alleged, it will be taken as evidence tending to show that the requirements of the building regulations have been met. But what you tend to find is that the majority of buildings which are designed in England and Wales are designed according to the requirements of that particular document. The fire protection requirements are calculated according to height, or they change according to the height of the building, and the height of the building is the height for access for the fire brigade. So the height tends to be the height to the top storey, like that. So fire precautions change according to the height of the building. There are alternatives to approved document B now. There are BS 9999 is an alternative to the approved document. It is out there, it is available. It's not massively widely used, but you can use it. A lot of the time, the fire resistance requirements in particular in the BS 9999 are lower than you'll find in the approved document. For example, an office building over 30 metres in the approved document would require 120 minutes fire resistance plus a sprinkler system. The same building in BS 9999 would require 75 minutes, so a reduction of 120 to 75. In the BS 9999, two-storey office buildings less than 1,000 square metres in plan can be left unprotected. You might think, well, there can't be a lot of those, but there are actually a huge number of those. There's a huge number of relatively small office buildings in this country, so that is quite significant. So approved document 9999 is an alternative. I quite like 9999 for a number of reasons. First of all, when you look at the approved document, in my opinion, there's an element to kind of suck it and see in terms of how it's been developed. In other words, what's happened is the rules have developed because we know that they work. But built into them, as we said, is quite a lot of conservatism. But 9999 is based on an understanding of what actually creates risk in fire. And if you actually look at what creates risk on fire, the four main factors on which risk is created are the height of the building, the familiarity of the occupants with the building, whether the occupants are asleep, and the degree of mobility. And of those, the big ones tend to be whether the occupants are asleep and their familiarity with the building. Which is why when we're in a hotel at the moment, one of the reasons why hotel fires tend to be so dangerous and why the management of hotels put so much emphasis on fire training for the staff is because those big two are there. People are asleep and they're not familiar with their surroundings. So the requirements of 9999 are a function of those sort of parameters. They're worked out on the basis of which of those sort of risks are there and to what extent they're there. 9999 also takes into account things like what is in there that can likely to be burned, what is the compartment size, and whether sprinklers are there. And it also recognises that in very tall buildings, this is something which is missing in approved document B, it also recognises that when very tall buildings over 60 metres, these are relatively rare despite the level of publicity that buildings like the Shard get, for example. They are relatively rare, but buildings over 60 metres are treated as special cases. That's as much as I want to say about 9999. Mainly we're here today to talk about fire and fire engineering. One of the critical things in the approved document is that the approved document does not try to be all things to all people. Because what it says is that if you're looking at large and complex buildings, you actually might not want to use approved document B in particular, that you will look at an engineered approach. So that statement, that's a direct quote. Fire safety engineering can provide an alternative approach to fire safety. It may be the only viable way to a satisfactory standard of fire in some large and complex buildings. That's a direct quote from approved document B. So for these types of buildings, it is pointing you, the approved document is pointing you towards an engineered approach rather than the approach of approved document B itself. And the Institution of Engineers, the Institution of Structural Engineers, they have a fire study group, and they have actually reproduced something like that. It says, by adopting a performance-based approach to structural fire engineering, more economic designs can be achieved, and more innovative and complex buildings can be constructed. So there's a lot of support for engineered approaches, both from the writers of the approved document and from the Institution of Structural Engineers. But moving on now, I'm going to talk a little bit about fire protection, structural fire protection in particular. There are three very common methods of structural fire protection, but by far the most common of these is an intumescent coating. And you can see them there, very often called intumescent paints. These are probably responsible for about 70% of all structural fire protection in the UK. Very, very common form of fire protection. For those of you who don't know what an intumescent coating is, that's what they look like when they're applied. But if you put an intumescent coating into a fire, it will swell and form a char, and it's that char that gives it its insulative properties. There is, in the United Kingdom, a very successful and very innovative off-site industry which applies this fire protection off-site. This has been, must be 15 years ago now since this was really properly developed, but it has been an immense success, and we're now actually exporting it. I'm hearing of projects in places like Denmark, the Ukraine, France, Germany, these sort of places which use this off-site process. The off-site process isn't the answer for every job because it is a premium process. It costs more to do the fire protection off-site than it does to do the fire protection on-site, but it has distinct advantages for certain types of projects, especially projects where the fire protection is on the critical path, where you have difficult site access, where weather dependency is an issue, that sort of thing. But it's been very, very successful, and it has been a great British innovation, very successful. And there are thousands, literally thousands of jobs which have been done off-site now, using off-site intumescent. If you're going to do fire protection off-site, it's very important that it's done properly, and therefore the SCI, and initially the SCI, and now the Association for Specialist Fire Protection, Wilf will be from the Association for Specialist Fire Protection, will talk after me, have produced a code of practice. And this includes typical contract statements as well, which effectively you can take them out of there and put them into your own contract documents if you want to do so. You don't have to use intumescent coatings. You can use different types of fire protection. You can use a board protection system. We saw that at the fire in Basingstoke. And you can use combinations. So this is a combination, a board fire protection system with an intumescent coating system. Board on the beams, intumescent on the columns. And boards are very adaptable. You can do a lot with them. You can put holes in them if you want to put them. You can use for surface penetrations. Or you can also sort of put them around complex shapes as well. So you're not constrained to just straight lines with board protection systems. And you can use various combinations. There are boards, there's two families of boards. There's heavy-duty boards, which you'd use for aesthetics, which are there, and lightweight boards, which you'd use generally where it's non-aesthetic, which you can see there. It's important you get the specification right because the cost differential is quite significant. You can also use spray protection systems. This is the stuff that was used on the beams at that Basingstoke fire. Again, quite popular. Anybody here who has worked in America in particular will probably have seen loads of this stuff. It's very, very widely used there. Much less common here, but it is used and it has its place. It's probably got about 5 or 10% of the market, I would say, where it is used. You can also use flexible blanket type systems. These are relatively rare. It surprises me that these are as rare as they are, but they are relatively rare. There's only 1 or 2 manufacturers. I think they're a very good product. They're a flexible, dry application, but as I say, they've never been massively, hugely popular in the industry, although they are very much a niche product, I think. We're fortunate in this country in that we have a very, very active fire protection industry. We have a lot of manufacturers, which creates a lot of competition, which creates a lot of research and development. And one of the consequences of that is that it drives down costs, and we keep a very close eye on costs. And this is a graph of fire protection costs over the last 10, 15 years. And it's on a downward trend. To be honest with you, I think structural fire protection is now pretty much as cheap as it's ever going to get. But there is a very, very active, very efficient and very, very effective structural fire protection industry out there. We're very lucky to have it. It provides structural fire protection, cheap and very reliable and very good quality fire protection out there. This is just a graph. I mentioned off-site fire protection. I keep a close eye on that as well. This is kind of the growth in market share of off-site fire protection. And despite the recession, it's tending to kind of keep its even though despite the recession and the fact that it is a premium product, it's tending to kind of keep its market share. It's there or thereabouts. So it is a good product as well. And this just gives you an idea of the changes in structural fire protection trends over the years. And you can see since the early 1990s, basically over the last 2 years, the green one is intumescent coating. And you can see the rise and rise of intumescent coating as a form of fire protection. And as I said, it's around about 70% now. And that's it. Thank you very much.